uh, Again will be welcome back to a pre-video of contest third module contest big grammar. Now today I'm taking cover of one of the important topic is simplified forms and normal forms. Right, simplified forms is in this we have there will be have some grammar. In that grammar there is a some complicated grammar are there, and some of the variables are useful and some of them are not useful, and some are nowhere it is using, and some are some useless variables are there. So one such problem is called nullable variable. So what is nullable variable? So nullable variable in any contest B grammar, that is VTSP, is defined as follows. So three conditions have to follow. Any variable, suppose A, for which P contains that A gives epsilon, is then A is a nullable variable. In another word, if P contains the production A gives B1, B2, B3, B etc. Bn are nullable, then again A is also nullable. So any other variables are nullable. So then no other variables are not nullable. So that is the these two conditions satisfied, then corresponding variables are nullable and corresponding productions are epsilon productions. So how to eliminate the eliminate the epsilon production? So you have see that x is a nullable variable, so you have to locate the x is available in even this production and find out the x, and which is a nullable variable. Then you have to write x. So this is you have to replace here, and this is there is no nullable variable. In place of x is replaced by epsilon, then we will get the A only. So what is the corresponding? Replacing x by epsilon in all production containing x on right hand and rewrite the production again. That is the meaning. So now you will see s gives ax or y and this. So finally you are removing all epsilon production. So this way you can find out. In simply another way you can find out the subset of x, you can find it, then you can easy to find out that. So eliminate the epsilon production. So again I'll see one more example. I'll take this example how to eliminate. Okay, after elimination of epsilon, a cap also it is an epsilon. Okay, so that A is a epsilon. So find out now. S gives is AC, because in place of A you have to replace epsilon, then you will get this production AC or C. And second also, wherever the A is there you have to replace that. It is okay. And this, and also this one, and I'll see one more example is here. I'll be back here. It is A gives A, B or AB, and there is no epsilon nullable variable in this C production. This will be the final production, right? Look at that in other way. So this is one more x is a nullable variable. Replace that x by x, ax and bx and y. So find out the subset of this. This will be like this. First x is replaced, ax will get. Second x is replaced by epsilon, it will get xa, and both the x is replaced, you will get a. Okay, A, and one more, that is a B. So this is x is replaced by B. Here it is B, x is already there. So this is very simple. Okay, next it is this also similar way, and similar to the S you have to replace. Okay, with this way it can be replace the epsilon. Then next topic is derivable. It's also called as a find out the useful variables. A variable is called a derivable. When you say it is a derivable, so it is a condition is A gives B is a production, B is a derivable. B is a derivable. If C is a derivable, how to conclude that C gives B is a production, then B should not equal to A, then B is a derivable. No other variables are a derivable. So this is one. Here it is example is S gives A, S gives B. S derivable A comma B. S gives A, A gives B is derivable A comma B. Unit production and elimination of unit production. Next topic is unit production and elimination of unit production. So look at that. Production of the form A gives B is termed as unit production where A and B are non-terminals. So production of the form A gives B is termed as a unit production where A and B are non-terminals. A algorithm is like this. A, right? So this is the way algorithm. We need to follow these steps, right? Each one of them, how to do that. So this algorithm, just for your explanation, for understanding purpose. So while applying these rules on removing for given grammar to eliminate the unit production, very simple way I'll explain it. Take an example. I'll take the example. You'll see the given grammar as unit production. S gives A and S gives B. Find out the unit productions, or there are S gives A and S gives B. I want to remove it. Removing unit production. How do you do that? Look at that. So A as a unit. A, look at that. So there is that A which is replaced by what? Non-unit production here, which is replaced by non-unit production of A. That is A is replaced by non-unit production of A. Similarly, B is replaced by non-unit production of B. That is which is replaced by this.